Hello everybody, my name is Pedro Cândido and today we are here to continue with our course on the ST-based disorders, okay? Well, first of all, I'd like to say sorry because we are having some construction right across the road here, so I'm sorry if you hear any construction noises, okay? But I think we'll be fine. And I would like to ask you to drop a like on this video, okay? And subscribe to the channel because it will help us a lot with growing our community, okay? We are giving some free knowledge for you guys, so please give a like and leave a subscribe, okay? And so, first of all, today we are here to talk about the mixed disturbs or the mixed disorders, okay? We can have acidosis, like we told, we can have alkalosis from different sources. We can have from the respiratory, we can have respiratory and metabolic, okay? Remembering that metabolic will come from the kidneys, okay? The kidneys regulate the concentration of bicarb on our body, okay? So, what is the mixed disorders, Pedro? Okay, we can have, for an example, we can have a metabolic acidosis together with respiratory acidosis. Okay, we can have the same disorders at the same time. Okay, we can have like respiratory acidosis with metabolic alkalosis. Okay, so Pedro, how do I see these alterations on the arterial blood gas? That's what we're here to teach you today, okay? And let's make some. We're going to work with some questions, okay? We will be learning by practice today. So first of all, let's look at the pH here. Okay, we have an acidosis. Okay, so what's the source of this acidosis, Pedro? Okay, and we can see that the bicarb is down and the PCO2 is also down. Okay, but a lower PCO2 would give us an alkalosis. Okay, so if we have an acidosis, the bicarb is the one to blame in here. Okay, this lower bicarb. So we need to first of all we need to use that equation that I taught you last class. Okay, we need to know the value of the PCO2 that would compensate this lower bicarb. Okay, so do you remember? Okay, the PCO2 will be equal to 1.5 times the oops the bicarb plus 8. Okay, so it will be 12 plus, times 1.5 will be 18 plus okay, we'll have the value of 26. Oh, Pedro, but 26 is already the value of the PCO2 in here. Okay, so this is a compensation. Okay, the lungs are okay, the lungs are compensating this lower bicarb here. So this is not a mixed disorder, this is only a metabolic acidosis in here. Okay, but what if we change this PCO2 value a little bit? Okay, we we still continue with an acidosis. Okay, the bicarb is still low, but the PCO2 is even lower. Okay, so what does that mean? Okay, the desired value for the PCO2 it continues to be 26. Okay, but the lungs they kind of hyperventilated in here and they eliminated more CO2 than we wanted. Okay, so what that will end up being, okay, we still with a metabolic acidosis, okay, I'll call MA in here, but we have another disorder in here. We have a respiratory alkalosis, okay, because the lungs are hyperventilating and uh, and are eliminating too much CO2 in this situation. Okay, remember if you have a higher PCO2, the pH goes up. If you have a lower PCO2, the pH goes. Sorry, if you have a higher PCO2, the pH goes down. If we have a lower PCO2, the pH goes up. Okay, so if a lower a lower pH will end up in an alkalosis situation, okay? But Pedro, the pH is still on a lower than 7.35. This is acid. Okay, it is. The main disorder here it's an acidosis, okay? But in the respiratory side, we are ended up with an alkalosis, okay? But the acidosis predominates over the alkalosis in here, okay? But we still with a mixed disorder in here. Okay, let's keep practicing so you end up understanding. Okay, so here what we have acidosis again. We have a pH of 7.12. Okay, and so what's the the one to blame in here? Again, it's a lower bicarb. Okay, the PCO2 it's almost normal. Okay, it's 32. It's a bit lower. Okay, so it's a metabolic acidosis. Okay, I'll also call it MA. Okay, Pedro. So what do we do here? We still need to calculate that value for the expected PCO2. So with a bicarb of 12, we've already calculated in here, it will be 26. Our expected value for PCO2, but Pedro, it's 32 here. Okay, so here, if with a lower PCO2 in this situation here, let me use the laser. Okay, with a lower PCO2, we ended up with a respiratory alkalosis. So here, uh, if we have a higher than the expected value, we'll call it an, a respiratory acidosis. Okay, guys. So we have a metabolic acidosis plus a respiratory acidosis. Yes, we have a mixed acidosis in here, okay? Or you can say that we have a metabolic acidosis with a respiratory acidosis, okay? I think you got it. Let's go to the next example. Okay, we have also an acidosis in here, okay? Uh, we have a metabolic acidosis because we can see that the bicarb is also lower, and we have a PCO2 of 34, okay? So it's a metabolic acidosis, okay? The expected value for the PCO2, it will also be 26 because the bicarb is 12. And again, we have a higher value for the PCO2, okay? So this is mixed acidosis again, okay? So let's go to the next one. Okay, we have a pH of 7.2. So this is acidosis again. Okay, but now we can see that the bicarb it's higher in its value. Okay, remember bicarb ranges from 22 to 26. Okay, with a middle point of 24. So we cannot call this acidosis a metabolic acidosis, okay? Because the bicarb is actually pushing the PCO2 up, okay, in this situation. But look at this value of the PCO2, guys. It's 70. It's way above 45. That is the maximum. Okay, let's remember that it's 35 to 45 with a middle point of 40 in the normal values. Okay, so uh, this PCO2 is causing the acidosis. Okay, so this is a respiratory acidosis. Okay, the main disturbing here. So now we need to calculate the value of the bicarb to compensate this respiratory acidosis. Okay, do you remember I taught you last class for every 10 that oh, sorry, because this is look trash. Okay, for every 10 in the PCO2 value above 40, we'll raise the bicarb by 4. Okay, so if it's 70, okay, we are 30 above, so okay, we need to add 12 in the bicarb from the middle value of 24. So here we are expecting a bicarb of 36. Oh, Pedro, we ended up with this value here, okay? So it's compensated. Okay, there is not a mixed disorder in here, okay? So we end up just with a respiratory acidosis in this situation, okay? But let's make things a bit different, okay? We just changed the bicarb value in here, okay? It's 22, okay? So we expected it to be 36, but it's actually lower, okay? So with a lower bicarb, what happens? Okay, we'll go to an acidosis side, okay? So this will end up being a respiratory acidosis with a metabolic acidosis, okay? So it will actually be again a mixed, okay, a mixed acidosis. But but remember, it's different from the last mixed acidosis that we saw, okay? The main disturb here is caused by the lungs, okay? It's a respiratory acidosis. Okay, let's go down here a little bit. We have the same values for the pH and PCO2, okay? We are still with acidosis, okay? With respiratory acidosis again, but the bicarb it's higher this time, okay? Remember we calculated our target for bicarb and it was 36 here, 36. So we are now in 44, we are above 36, okay? So this will end up being a respiratory acidosis with a metabolic alkalosis. Okay? Did you guys get it? So I think you will be here. We'll end up here with this class. I think you. Okay, I expect you all to be taught very well today. That you understood the assignment for today of the mixed disorders. So I'm sorry for my poor English for now. I'll be trying to improve as we go with the classes. Okay. Don't forget to leave a like and subscribe to the channel. And I see you soon in the next class. Bye bye.